Alright folks, welcome to your solutions. Let's check them out. First question is to name the special segment for 1 through 4. Okay, so for the first question, I see that we have some kind of a line segment. It starts from a vertex A. It goes to the other side and chops the other side in half. And these two tick marks tell me that this segment CF is equal to this segment BC. So that means line segment AC chopped the other side in half. That means line segment AC is a median because it hit the middle of the other side and chopped it in half. Next one up, we've got line segment HE. Okay, HE. So what do we see for that one? Well, we see a few things. Number one, we see a right angle, and we see that HE has chopped the side in half. So this part of the side is equal to this part of the side. How do we know that? Well, you can just look at these tick marks, and these two tick marks tell you that this side, DE, is equal to this side, EF. So EF is equal to DE. That means HE not only hit the side at a right angle, it also chopped the side in half. That means we're talking about a double whammy, and that means we're talking about a perpendicular because of this right angle. Bisector, perpendicular bisector. And why is it called a bisector? Well, it bisects the side, right? It cuts the side in half. Next one up, we have line segment JL. So if you look at this line segment, you'll notice a couple of things. You'll see that this angle, wow, this highlighter is like, geez, man. So let me get cyan up here. So you'll notice that this angle over here, angle LJI, is equal to this angle, angle KJL. So those two angles are equal. So if those two angles are equal, that means this bigger angle was cut in half by this line segment. It was cut in half by this line segment JL. So the big angle was cut in half into two equal angles. This green angle and this orange angle. So if you have something like that, something that cuts an angle in half, well, that's an angle bisector. Next one up, we got a line segment PN. So what do you have here? Well, you got a line segment that starts from a vertex, goes to the other side and hits it at a right angle. Soon as you hear the word right angle, you should think of altitude. And that's exactly what this is. Okay, let's move on. Let's see what we got up here. Alright, so this is one nasty table, but we're going to go ahead and look at the pictures first. Where's my pictures at? Okay, so this is the old version, but we're still going to draw the pictures. Okay, and the pictures are going to help us fill out this table. So first of all, a median. What does a median look like? So a median is going to look like this. So we have some kind of a triangle, and let me actually draw my triangle in black so I can do the rest of it in colors. So here's my triangle. And let's say I want the median for this side. So I'm going to start from a vertex and cut the other side in half. And so that's a median. That's it. So does my median, let's go step by step. Does my median pass through a vertex? Well, yeah, it started from here. So yes. Does my median go through a midpoint? Well, yeah, I mean, that's the whole point of a median. It goes through the middle of my side. So yes, it does go through a midpoint. Does my median form a right angle? Well, this one can be a bit tricky, but look over here. If you look at this angle, it looks like an obtuse angle, not a right angle. So just by looking at the picture, I would say no. And of course, draw the picture. Well, here's the picture. Here is your picture. Okay, next one up. Our next kind of line segment we're going to look at is the altitude. So let's draw a picture of that. So again, here's a triangle. So here's my triangle. And I'm going to go ahead and draw the altitude to this side. So I'm going to start from a vertex, and I'm going to drop my altitude at a right angle to the other side. And let's fill out the questions. So first of all, does it pass through a vertex? Well, yeah, here's my vertex. So yes. does my altitude go through a midpoint? Not really. I mean, does this look like the middle of that side? No, the middle of this side is probably here. The altitude ends up here. So no, the altitude does not have to go through the middle. So no. Does my altitude form a right angle? Well, yes it does. Yes it does. So yes. And draw a picture. Well, we got that right here. Next one up is an angle bisector. So let me go ahead and draw my picture. Here's my triangle. And let's say I want the, so let's say here's my angle. And I want the angle bisector for that angle. Well, I'm going to go ahead and chop that angle in half. So this part of the angle is equal to this part of the angle. Let me finish that up there. And so now let's answer the questions. First of all, does my angle bisector pass through a vertex? Well, yeah, look over here. And you'll see that my angle bisector starts from a vertex. So yes. Does it pass through a midpoint? Well, again, the midpoint of this side is around here, or maybe even further right. Maybe the midpoint of this side is here, but the angle bisector is here. So clearly, my angle bisector does not have to pass through the midpoint. So I would say no. And does my angle bisector form a right angle? Well, check it out. Does this look like a right angle? Looks kind of acute, and actually it depends. The answer depends. So it doesn't necessarily have to form a right angle. So the answer is no. The angle bisector does not have to form a right angle. And for the final one, draw a picture. Here it is. And if you want like a more kind of intuitive understanding of this, try the simulation. It's really cool. And it'll help you understand all of these types of special segments for all kinds of triangles. It's really cool. Finally, the last one up is the perpendicular bisector. Let's draw a picture for that one. So here's my triangle. And let's say I want the perpendicular bisector to this side. Let's make it a little fun. So first of all, I know I want to chop this side in half. So midpoint, the halfway point is probably around there. And I want my perpendicular bisector to chop it in half at a right angle. So here's my right angle. Okay, boom. So let's fill out the questions now. So the first question is, does my perpendicular bisector pass through a vertex? Well, no, right? Look, is this a vertex? Is it a corner of the triangle? No. What about this? No. So yeah, what about this? No, that's not a corner of the triangle. It's a point on the triangle, but it's not a corner. It's not a vertex. So the answer to the first question is no. The perpendicular bisector does not have to pass through a vertex of the triangle. Next one up, does it pass through the midpoint? Well, yeah, check it out. The perpendicular bisector chops the side in half, so it has to pass through the midpoint. Does it form a right angle? Well, yeah, that's why it's perpendicular, right? You can see that right angle right here. So yes. And draw a picture. Well, our picture is right here. By the way, if you're looking for the answers, the solutions to the four drawings, the four pictures, well, we got that in the small and big hints. So go ahead, watch those for the solution to that. Let's keep going. 3 or more lines that intersect at a common point are called. So if you have 3 or more lines, so let's draw it out. Here's one line, here's another line, here's a third line, and they intersect at a common point. So that's called concurrent. Those 3 lines are concurrent, okay? Parallel lines are lines that never meet, okay? That's how parallel lines look like. Perpendicular lines are lines that meet at a right angle. So that's how perpendicular lines look like. And concurrent lines, that's the answer, they look like this. All right? So 3 lines meeting up at a common point. That's concurrent lines. Okay. Next one up. Let me go ahead and circle it so people just know. Our next one up is any point on the perpendicular bisector of a segment is, let's erase these so we don't get confused. So any point on a perpendicular bisector of a segment is blank from the endpoints of the segment. So what does that mean? So let's draw a picture. So let's say I have some kind of a line segment and I draw the perpendicular bisector of that line segment. So the perpendicular bisector hits this line at a right angle and chops this line into equal pieces. So this piece and this piece, they're equal. So I'm gonna go ahead and put tick marks here. Okay, so this line segment is chopped in half by a perpendicular bisector that hits the line segment at a right angle. Okay, so any point on the perpendicular bisector, so for example, if I choose this point on the perpendicular bisector, you'll see that it's actually equidistant. It's the same distance, in other words, from the endpoints of the segment. So this is equal to this. Okay, so the answer would be equidistant from. And if you still don't understand why, go ahead, check out the simulation. Super cool. Okay, next one up. C. Blank blank or blank of a triangle is a segment drawn from the vertex of a triangle perpendicular to the line containing the opposite side. Okay, so here's the key word, perpendicular. Can you think of something that's perpendicular to the opposite side? Something that starts from a vertex? Well, there's only one thing, and it's an altitude. Remember, an altitude starts from a vertex, right? Here's my vertex, and it hits the other side at a right angle. Perpendicular bisector doesn't have to start from a vertex. It can start anywhere. But altitude has to start from a vertex. That's why the answer to C is an altitude. Next one up, the point of concurrency for three perpendicular bisectors of a triangle is called. So, when you have three perpendicular bisectors, where does it meet up? So, this is just a kind of vocabulary word, and if you don't know how this works, go ahead, check out the big ideas simulation. So here's the simulation, as a matter of fact. Let me show it to you. So let's go to the last part of the simulation. So let's check out the perpendicular bisectors. Where do they meet up? Do you see where they meet up? This is where they meet up, this purple point. And there's a special name for this point. The perpendicular bisectors meet up at a common point called the circumcenter. And for the last question, the point of concurrency for three angle bisectors of a triangle is our incenter. Okay, so just keep those vocab words in mind. If you still don't understand them, we're going to touch on them later on in the course. Next question. If BE, which is this, is equal to EC, which is this, AE is what kind of special line segment? So since AE chops up this line in half, AE is going to be a median. Next one up, we have in the triangle below, what type of special segment is AE? Well, check it out. It starts from a vertex and hits the opposite side at a right angle. And so this right here, this guy, is an altitude. Next one up is this one, number 3. If BK, which is this, is equal to KC, which is this, what type of line segment is this special blue line? Well, check out what we have here. Not only do we have a right angle, but not only do we have this right angle, we also have this part of the triangle chopped in half. So think about it. A right angle, a side of the triangle chopped in half, we're talking about a double whammy, aka a perpendicular bisector. Not only does it meet the side at a right angle, it also chops the side in half. So it's going to be a perpendicular bisector. Alright folks, that's the solution manual for this lesson in geometry. Hopefully that helped you out. Check you out next time.